want to do a test. Say I want to do a test. Give me a value we want to test against. Okay, mean weighted cat. So basically, we want to know the mean of the cats is less than. Okay, what did they say it was 10.34?
10.63.
Okay, let's look at this thing. 10.63. What else do we need to know in order to do a t-test? I want to test the mean. What else other do I need to know? I need standard deviation of h weight. And I also want to know the length. How many variables do I have? I mean, how many observations do I have? Length of h weight. Okay. So we got that. I want to run these guys. Oh, I didn't include that. That's what happened there. I only had VHP and h weight. Did I spell that right? I did. 144. 144 observations.
So length gives you the n?
Huh?
Length is the command to get in.
That's the length of, length gives you how many variables you have. How many observations you have. Okay? If I only have one variable.
Gives you the n for that variable.
Here's another command you can use. I can use this command. Cats is sort of a matrix, right? I can go dim. I can go dim of cats. What do you think dim means? Dimension. I can go dimension of cats. What do you think that'll tell me? 144 by 3.
3 categories.
What does that mean? There are 3 variables and 140 rows by columns, right? So it means you have 144 rows and 3 columns, and the 3 columns refers to, I think, sex, B weight, which is before weight, and H weight, which I think is after weight.
Heart weight.
Heart weight? Yeah. Okay, so B weight is body weight, heart weight. One of the other. One would be body weight, and the other one's heart.
Let's try to figure out what they're measuring.
Okay, so we got that.
So
we got that. Standard deviation is 2.4. 144 is 12.
Plus one was taken off from the
Divided by that, it's going to be 5.
but I mean, it's better than testing.
Okay, so the thing I want to do here, I want to test, is this less than, is the mean of, if this is heart weight, the mean of the cat heart weight, is that less than, let's say, 11.2, or is the mean cat heart weight greater than 11.2, right? This is H naught. HA, okay. So how would I do the test? As I want to test it 0.05, right? What's the test? Basically, I want to see if I have an extreme value, right? So I want to see if it's less than that. So basically, I'm going to go over here and I'm going to go, okay, I'm going to have a comment line. So basically, I want to know if it's going to be, I'm testing 11.2. So basically, I want to know is the mean of X less than 11.2 plus T 0.975. How many degrees of freedom do I have? 143, right? Times S divided by SQRT of 144, right? Good. Okay? Isn't that in general what I want to do? I'll accept. I'll reject H naught, H0 if that's true, correct? I'll accept H naught, I'll reject H naught if it's greater than, whoops, I'll reject H naught if this is true, correct? If I get some extreme value, assuming 11.2 is the mean, then I'd reject it, correct? So basically, what am I going to have here? So basically, the test is going to be, so basically I'm going to look at X bar, so I'm going to get the mean of, okay, I'm going to compute the mean of X. Well, I know what the mean of X is. What did I say it was? It's 10.63. So the only thing I need to do is compute this value over here. So it's 11.2 plus what? So it's T, so it's going to be QT. Whoa, what's this one here? 11.2 plus QT of 0.975. How many degrees of freedom do I have? 43. What's S? So basically it's going to be, it would be SD of HWT, correct? Divided by SQRT of 144, right? Which is what? Anyway. Should be, anyway, we get that. So we'll run this.
I'm like, come on.
This thing? It's 11.660. So is my mean 10.63 greater than 11.60?
No.
So what do I conclude?
Have to accept the null hypothesis, or you do not reject.
You do not reject the null hypothesis.
Do not reject the null, but it's less than 11.2, correct?
Correct.
Okay.
Go, Stacy.
So now we can go and say, okay, so at the 0.05 level of significance, oh, I shouldn't have done that. I did a one-sided test, so what should this be?
I thought we were doing a one-sided test.
Yeah, so I did a one-sided test, so what should this value be? That should be 0.95, right? I did the alpha over 2 again. So there, we made a mistake. I'll run it again. So basically, is X bar greater than 11.53? No, it's 10.34, correct? Okay, how about if I did another test? Say I assumed it was, let me assume that it's greater. Let's do the opposite one. Let's assume instead of that, so for one we're going to do that. Let's assume the same thing. Let's assume it's greater than 11.2 and HA that it's less than 11.2. What's the test? What's the test? The test is basically
the same, just
except I'm just going to, this
subtract.
is going to be minus, and this, oh, see, I made a mistake there, that should be 0.5, that should be 0.5. So this will be, we're going to look at this, right? We're going to look at this now, we're going to look at the minus, we're going to run that, and we're going to go, oh, it's 10.864. So is, what did I get? I got 10.34 for the mean, right? What is the mean?
10.63.
The mean is 10.63, correct? So I don't want the mean, I want the mean of HW. Okay, so 10.63 is less than 10.864. So basically, what am I going to do on this hypothesis? Under this one, I'd reject this and accept that, right? That makes sense?
Mm-hmm.
Okay, cool. If I did the equality one, it's the same thing, right? Now the thing you may say to, well, you say it failed at, you can say it failed at 0.05%, but then you can think to yourself, well, how extreme was that value that I saw, right? You can go, how extreme was that value? So basically, when I did this whole thing over here, what did I do? I arbitrarily, you can't do it with that one. Alrighty. Alrighty. So when I do all this stuff, the thing I do is when I set a test, I set this to begin with, right? I set that to begin with, and then I go, okay, I'm going to do it. If I do pre-planning correctly, and I set up my type 1 and 2 errors correctly, I'm going to be testing at a certain level, and I'm going to pick the sample size based on the power of the test. But I don't have enough time to go through all that to get through this whole thing. I could spend about 2 weeks going through all that stuff. So basically, calculate. So I set this in advance, and then I run my test. But then when I'm done, I go, okay, it failed at, you can say it passed or failed at 0.05%. But then you can ask yourself, I sort of set this arbitrarily, not arbitrarily, but just through the type of, I set the type 1 error that I wanted, and then just went to work and did my work. But then you can ask yourself, say, geez, would it have passed at any level? I mean, what level would it have passed or failed at? And then what you can do is look at something called the p-value. This really became prevalent when people started doing a lot of social statistics and everything.